Let's be real. AI summaries are everywhere now, right? They're in our search engines, our research tools, even our web browsers. And they all make this big promise to save us a ton of time by boiling down long, complicated stuff into just the key points. But here's the thing. They don't all work the same way, not even close.
You know that little AI summary button you see? You've probably clicked it a million times. An answer just appears. It feels so simple. But what's actually happening behind the scenes when you click that? And is the summary you get from one tool going to be the same as another? Well, the short answer to that is a hard no.
So to really get what's going on, let's think about this as a journey through 3 different levels of complexity. We're going to start with the basics, like an assistant that just reads one document for you. Then we'll move up to an organizer that helps you compare a bunch of them. And finally, we'll get to the full synthesizer, the AI that tries to create totally new answers from all that information.
All right, let's dive into level 1. This is the one you're going to see most often. It's where the AI is focused on just one single document at a time. This is kind of the bedrock of all AI summarization, but even at this foundational level, there are some really important differences. See, level 1 isn't just one thing. It comes in a few different flavors. First, you've got the simple fixed button. You click it, you get a generic summary. Pretty low risk. Then it gets a little smarter with query-dependent summaries, where the AI actually looks at your original search to tailor the summary. And then there's the whole chat with PDF model, where you can ask it literally anything you want about the document. And that's where you can really see the pattern. The more freedom you get, the higher the risk of the AI getting something wrong.
And this gets to a really important point. It's a trade-off. That simple, fixed button, super predictable, super low risk. But the second you get the freedom to ask any wild question you can think of, the system gets way less predictable. And the chance that it messes up or, just makes something up, what we call hallucinating, it goes way up.
Okay, so now let's level up. Level 2 is where things start getting really interesting. We're still technically looking at one document at a time, but we're doing it over and over again, in sequence, for a whole list of search results. The goal here isn't just a paragraph summary, it's to build a whole table of evidence. Think of it like an AI creating a research spreadsheet for you on the fly.
Just picture this for a second. You do a search, and instead of just a list of blue links, the AI goes out and reads the top 10 articles for you. And for every single one, it pulls out the main finding, maybe the method they used, and puts it all into a nice, clean table. That is the magic of sequential summarization. So what does this actually look like? Well, take a look at this. We asked about the open access citation advantage. The AI went through 3 different papers. You can see right away one says, yes, there's a 15% increase, another says, nope, no effect, and a third one says, well, it depends on the field. In an instant, you see the entire conversation in the research, including the disagreements, all laid out for you.
There's another really cool thing about this method. It's a fantastic filter. If a paper in your search results isn't actually about your question, the AI is just going to struggle. It won't be able to fill in that column in the table. And that empty box, or one that's full of nonsense, is a giant red flag telling you, hey, don't bother clicking this one. It's not relevant. And that brings us to level 3. This is the big one, the holy grail of AI summarization, you could say. This is what a lot of us think AI is doing all the time, reading a whole stack of documents and then weaving them all together into a single, brand new answer. This is the incredible promise, but also the massive peril of a technique called Retrieval Augmented Generation, or RAG for short. So, what is RAG? Basically, it's a 2-step dance. First, the retrieval part goes out and finds a bunch of documents it thinks are relevant to your question. Then, the generation part, that's the large language model, tries to read across all of them at once to write a single cohesive paragraph. It's moving from being an organizer to being an actual author. But here's the catch. Doing this well is incredibly hard, and it can fail in a few different ways. First, if it retrieves the wrong documents, well, garbage in, garbage out, the whole thing's a bust from the start. Second, it still has to summarize each paper correctly. But the biggest challenge, the place these systems fall down most often, is handling contradictions. What is it supposed to do when one source says yes and another source says absolutely not? Researcher Aaron Tay just nails the core of the problem with this quote. He says that large language models are credulous. They basically believe everything they read. They'll treat a tiny, badly designed study with the same authority as a huge landmark paper. They just don't have that critical judgment to weigh the evidence properly. And this right here shows you exactly what that failure looks like in the real world.
A good researcher and an ideal AI would point out the disagreement. It would say, hey, source A found this, but source B, which is a bigger study, found the opposite. But what usually happens with RAG systems, they just kind of smooth over the conflict. They'll say sources A and B both discuss the effect, completely ignoring the most important part of the story, which is that there's a real debate going on.
Okay, so with all that in mind, what are we supposed to do about it? How do we use these tools without being misled? The goal is to shift from just being a passive consumer of these summaries to being a smart, informed critic. And you don't have to be some AI expert to do it. You just need a couple of simple tricks up your sleeve.
Look, even the top researchers are still scratching their heads about how to perfectly and formally test these systems. It's a huge unsolved problem. But for us, as users, we don't need all that. We can run a few quick and easy sanity tests that are surprisingly good at showing you where a system's limits are.
So here are 3 quick tests you can run on any AI summarizer. First, the negative test. Ask it something you know for a fact is not in the documents. Does it make something up? Second, the attribution test. Click on those little citation numbers. Do the sources actually say what the AI claims they say? And finally, the contradiction test. Give it a topic where you know there's a debate and see what it does. Does it tell you about the conflict, or does it just pretend it doesn't exist?
But listen, if you only have time for one test, this is the one, the negative test. The best possible answer a reliable AI can give you is sometimes, I don't know. A system that has the honesty to say, I'm sorry, I can't answer that from the sources I was given, is infinitely more trustworthy than one that just confidently makes up an answer.
And all of this leaves us with a pretty big question, doesn't it? These AI tools, they're becoming the first draft of our knowledge, the first filter for so much of the information we consume. And as they get more and more powerful, we really have to ask ourselves, who's going to have the final say on what's true? That's definitely something worth thinking about.